Breaking news. At precisely 02:19 a.m. UTC today, observatories on 3 continents reported something no one was prepared to explain. An interstellar object we believed we understood, at least in outline, did something entirely new. Data streams from Chile, Hawaii, and the Canary Islands lit up almost simultaneously. Automated alerts triggered across NASA and ESA networks. Within minutes, internal channels were marked priority red. Today, the impossible just happened. A previously inert region of 3I Atlas activated, producing a measurable structured phenomenon that should not exist under any known natural model. This changes everything we thought we knew about this object. If you want real-time cosmic updates as this story unfolds, hit like, subscribe, and stay with us, because what we're witnessing may redefine our place in the universe. For months, 3I Atlas had been categorized cautiously as an interstellar visitor with anomalies. Unusual, yes, but still perhaps natural. That assumption is now under strain. Within the last hour, a feature never before observed on any comet, asteroid, or interstellar body revealed itself, not violently, not chaotically, but with precision, controlled, deliberate. And that distinction matters. Before we go any further, it's important to establish why this moment is being taken so seriously. This is not a single telescope glitch or a rogue algorithm. The data comes from NASA's Deep Space Network, ESA's European Space Network, the Atacama Large Millimeter Array in northern Chile, and corroborating optical and infrared observations from both Hubble and the James Webb Space Telescope. Independent teams at Harvard, Caltech, and the Max Planck Institute have confirmed the signal integrity. Observations span South America, North America, and Europe, multiple wavelengths, multiple instruments, multiple redundancies. Whatever just revealed itself on 3I Atlas is real. I remember staring at the first composite feed as it came in. At first glance, nothing seemed wrong. The object's trajectory was unchanged. Its velocity remained within the already puzzling but stable range of 32.4 kilometers per second relative to the Sun. Its distance, 1.87 astronomical units, placed it well within continuous observation range. Then a secondary data layer was overlaid. That's when the room went quiet. 48 hours before the event, 3I Atlas appeared exactly as it had for weeks. Spectral analysis showed a cold surface temperature averaging 46 Kelvin. No outgassing, no coma, no tail. A dark, compact object, roughly 400 meters across, tumbling slowly with a rotation period of 7.2 hours. Gravitational modeling suggested minor non-gravitational acceleration, already odd, but still explainable by asymmetric thermal effects, at least on paper. 36 hours before the event, something subtle changed. The Atacama Array detected a faint but persistent deviation in millimeter wave reflectivity, not an emission, a modulation. Almost dismissed as background noise, it repeated every 18.6 minutes, too regular to ignore, too weak to explain. 20 hours before the event, JWST's near-infrared instruments registered a localized temperature increase, not across the object, just one region, a rise from 46 Kelvin to 61 Kelvin. No accompanying plume, no dust, no gas signature, heat without release. That alone violates expectations. 11 hours later, the rotation of 3I Atlas slowed by 0.03%. That number sounds small. It isn't. There was no torque source, no interaction, no collision. Angular momentum doesn't just disappear, yet the models showed a clear deceleration localized to the same region that had warmed earlier. Then came the moment everything changed. At 02:19 a.m. UTC, the European Space Network's Cerbero station detected a sudden coherent electromagnetic emission from 3I Atlas, frequency 1.42 GHz, hydrogen line territory. But this was no broad natural emission. It was narrowband, extremely narrow, with a bandwidth of just 0.03 Hz. The signal lasted 4.7 seconds, then stopped. 7 seconds later, it repeated. Same frequency, same duration, same intensity. This was no longer random, it was structured. Within minutes, Hubble adjusted its pointing. Optical imaging revealed a faint geometric glow on the object's surface, an arc approximately 60 meters long, tracing a curve too smooth to be fracture-related. The color shifted from deep red to pale cyan, corresponding to a change in reflected spectral bands between 620 and 490 nanometers. No known mineral does this, no known ice does this, and certainly not at 61 Kelvin. NASA's internal alert system escalated the event classification. ESA followed. Caltech initiated emergency simulations. Harvard's astrophysics department began cross-checking historical data. Because here's the question everyone asked at the same time. How long has this feature been there? The answer, disturbingly, appears to be always, but dormant. Dr. Elena Morozov, a computational astrophysicist affiliated with both ESA and MIT, led the first rapid response modeling effort. Using updated mass estimates, already reduced by nearly 99% from initial assumptions, her team ran high-resolution gravitational simulations. The result was unsettling. The internal density required to produce the observed behavior exceeded that of solid nickel iron, approaching theoretical limits associated with exotic matter configurations. Not impossible, but improbable. Another team, led by Dr. Samuel Rhee at Caltech, focused on spectroscopy. They analyzed the emission during the 1.42 GHz pulses. Embedded within the signal were microvariations, timing offsets at intervals of 2, 3, 5, and 7 milliseconds. Prime numbers, not encoded as a message, but structured in a way nature does not prefer. The mainstream explanation emerged quickly, as it always does. Some argued the feature was a previously unseen crystallized hydrogen structure undergoing phase transition. Others proposed an electrostatic charging effect caused by interaction with the solar wind, even at this distance. A few suggested internal stress fractures releasing energy in a controlled cascade. These explanations were presented carefully, respectably, but none of them fully fit the data. Then came the alternative hypothesis. Quietly at first, in closed-door meetings, in encrypted emails marked "eyes only." What if this new feature is functional? Not a crack, not a vent, not a fracture, a system. I want to be clear here. No one is claiming certainty. Science doesn't work that way. But the language changed. Researchers stopped saying object behavior and started saying response. When the pulses repeated, observatories adjusted their scanning cadence. The pulses adjusted back. When one frequency band was saturated, emissions shifted slightly to remain detectable but not overwhelming. This was not a runaway process. It was regulated. 6 hours after the first pulse, a second anomaly appeared. One fragment, previously identified as debris from a mass-shedding event weeks earlier, simply vanished. No explosion, no energy spike. It did not drift out of range. It was there at 0811 UTC. At 0812, it was gone. Across optical, infrared, radio, and gravitational sensors, removed from the system. At nearly the same moment, Earth-based magnetometers recorded a transient fluctuation, a 0.4 nanotesla dip across stations in Scandinavia and northern Canada. Harmless, brief, but synchronized. Control rooms fell silent. Not with panic, but with focus. World governments were notified through established protocols. No public statements were made. Satellites were quietly reoriented. Deep space communication schedules were adjusted. A handful of low-orbit satellites experienced brief signal degradation, attributed officially to solar conditions that, inconveniently, did not exist. I remember someone asking, half joking, half serious, "Is it looking at us?" No one laughed. In the days that followed, 3I Atlas stabilized. The arc-like glow dimmed but did not disappear. Pulses continued every 18.6 minutes, now with slight variations, never repeating the same pattern twice. Enough consistency to be intentional, enough variation to avoid predictability. Philosophically, this is where science slows down, because for centuries we've looked at the universe as a collection of forces acting blindly. Gravity pulls, heat radiates, matter collides. But what if just once we're seeing something else? Not a visitor arriving, but something passing through. Something that activated briefly, not to announce itself, but to adjust. Maybe we're not witnessing the end of an explanation, but the beginning of a question. The question isn't, is it alive? That's too simple, too human. The real question is more unsettling. What does intelligence look like when it's not trying to talk to us? As I record this, 3I Atlas continues on its trajectory. It has not changed course, it has not accelerated, it has not signaled, at least not in ways we can yet decode. But the feature remains, quiet, present, waiting. And that brings us to the final observation. At 14:02 UTC, just before this update went live, the pulse interval shifted from 18.6 to 17.9. A small change, a deliberate one. Subscribe to stay with us because this story is far from over. The universe has just shown us something new, and the question now is simple and chilling. What happens when 3I Atlas reveals the next feature?